In mathematics, mean, median, and mode are measures of central tendency that help to summarize and analyze datasets by describing a central or typical value within a dataset. They each provide unique insights into the nature of the data, and understanding their differences and applications is key to accurately interpreting information. Additional concepts such as range, outliers, and measures of spread further enhance our understanding by providing context about the variation and distribution of values within a dataset. The mean, commonly referred to as the average, is calculated by adding up all the values in a dataset and then dividing by the number of values. The mean is a useful measure for datasets where the values are evenly spread out and do not contain extreme values. However, the mean can be heavily affected by outliers, which are values significantly higher or lower than the others in the dataset. For instance, if one person in a group of people earns a much higher income than everyone else, the mean income will be skewed upwards, making it less representative of the typical income. In such cases, other measures such as median and mode might give a clearer picture of the typical values in the dataset. The median represents the middle value of a dataset when the values are arranged in ascending or descending order. If there is an odd number of values, the median is simply the middle value. If there is an even number of values, the median is the average of the two middle values. The median is particularly useful when a dataset contains outliers, as it is not affected by them. This makes the median a reliable indicator of central tendency in cases where extreme values might distort the mean. For example, in a dataset of house prices where most properties are moderately priced but a few are significantly higher, the median price will give a clearer indication of the typical price than the mean, as it does not get pulled towards the extreme values. The mode is the value that appears most frequently in a dataset. Unlike the mean and median, the mode does not require numerical calculations and can be used for both numerical and categorical data. For instance, in a survey asking people for their favorite color, the mode would simply be the color chosen by the most respondents. Some datasets may have more than one mode, which occurs when multiple values appear with the same highest frequency, making them bimodal or multimodal. Conversely, some datasets may have no mode at all, if no value repeats. The mode is particularly useful for identifying the most common outcome in a set of discrete data and can provide a valuable sense of typicality when dealing with qualitative data. Alongside these central tendency measures, the range gives us a sense of the spread of the data by indicating the difference between the highest and lowest values in the set. Calculating the range is straightforward. Subtract the smallest value from the largest. A small range suggests that the data points are clustered closely around the central values, while a large range indicates more variability within the dataset. However, like the mean, the range is susceptible to being influenced by outliers. In cases where extreme values are present, additional measures such as the interquartile range or standard deviation may provide a more accurate sense of the data's spread. Outliers, values that are significantly different from others in the dataset, can have a substantial impact on these measures. In addition to skewing the mean and range, outliers can affect how the data is interpreted as a whole. For instance, if a dataset of students' test scores has one unusually low score due to illness, this outlier will lower the mean, potentially giving the impression that overall performance was lower than it actually was. Identifying and understanding outliers is essential in data analysis, as they can reveal important trends or errors within the data. In more advanced analysis, measures of spread such as variance and standard deviation further enhance our understanding of datasets by quantifying how much the values deviate from the mean. Variance calculates the average of the squared differences from the mean, while standard deviation is the square root of the variance, giving a measure in the same units as the data. These measures allow us to see how clustered or dispersed the values are around the mean, providing deeper insights into the consistency or variability of the data. In summary, mean, median, and mode are three distinct yet complementary measures that help us understand the central tendency of a dataset. While the mean offers an overall average, it can be skewed by outliers. The median provides the middle point, unaffected by extremes, and the mode highlights the most frequent value, useful in both numerical and categorical contexts. The range, along with variance and standard deviation, gives further context by showing the spread and variability of the data, while recognizing and accounting for outliers ensures that the data interpretation remains accurate and meaningful. Together, these measures provide a comprehensive toolkit for summarizing and analyzing data in a way that captures both central values and variability, enabling us to draw clear and informed conclusions.